between the platitudes of how transformative artificial intelligence is and what is exactly happening on the ground within firms, there falls a big shadow. Our first conference revealed that a few large firms are leading the artificial intelligence revolution, but it is beginning to permeate the whole economy. The big problem is, despite the large amount of artificial intelligence we have, we are not really able to pin down the facts with hard data. And so little is understood about who is using artificial intelligence, how, who is not, and why, and how use might evolve over time. Most of all, we want to understand how artificial intelligence is going to affect growth and living standards. And that means understanding how it's going to affect productivity within firms, the utility of individuals who use it or benefit from the products, and also the well-being of the workers. Now, there's no doubt that artificial intelligence has tremendous potential, but we here in the World Bank are also concerned about the benefits which will accrue to poor people and poor countries. And here there's one big concern, because the data that feeds artificial intelligence is very unevenly distributed. And there is a concern that since the data that is used to train artificial intelligence comes from particular people, particular communities, and even particular countries, the predictions that come from artificial intelligence might also contain some biases. Now, addressing these questions is really profoundly important if you're going to ensure that the benefits of artificial intelligence accrue to everybody all over the world. And which is why I'm thrilled to have here so many smart people, people from the firms themselves, the protagonists of this whole revolution, people from academia, and also policymakers. And I'm particularly happy to have a leading light from this field, our Professor Catherine Tucker from MIT Sloan, who has thought harder about many of these questions than most people, and is a global expert. And she, apart from being a professor at MIT Sloan, is also the principal investigator of the NBR Economics of Digitization project. So, Professor Tucker, welcome.
Oh. Well, that was an absolutely fantastic introduction, but it was particularly fantastic because in some sense you said my big punchline, which is what I think we're hoping that you're going to gain from the day, is that in the end we're all excited about machine learning, we're all excited about artificial intelligence, where it may take us, but in the end this is a data-fueled technology. And just questions about the data that is going to fuel this technology really should inform our understanding about what its global impact may be. And we want you to just take that away from what we're going to do. And I know it's going to be a recurring theme throughout the sessions today. Now, you've heard I'm a professor, so in terms of a keynote, I'm going to warn you there's going to be some numbers. There may even be an equation, just to sort of set expectations. But before we get there and tell you what I'm going to talk about, which is some evidence about how missing data can distort artificial intelligence, I just want to talk a little bit about how we in economics think about artificial intelligence. And in some sense, this is the transition from the event we had in May, where the keynote speaker was Avi Goldfarb, who introduced some of these ideas. I just want to remind you what was said then, and then we can start to move on to my talk, which will be more about the data piece. Now, the history of the economics of AI is that it's a very short-lived field. It's been around for, I think, 5 years as a field. And it came together from a group of economists under the National Bureau of Economic Research, noticing that there was this AI revolution going on, and trying to think, well, how is that going to affect how we're going to think about economics? Now, we've made two big steps in that field in the last 5 years, and let me tell you what they are, because I think they're useful insights. The first insight we had in around 2018 is that perhaps we'd always been dismissive as a field in economics about AI because it sort of felt like it was about Terminator Judgment Day. It was about robots becoming intelligent, something like that, right? They didn't see it as something that economists can really say anything about. But back in 2018, we actually realized that AI, it's not about robots. It's actually about prediction. And what we should, as economists, be thinking about is how do economies change when the costs of prediction dramatically fall. And so that's how we started off the research agenda, saying we can now predict stuff more cheaply, more easily. How is that going to change the economy? And we thought about that in terms of how firms and customers might relate. We thought about how it's going to affect job markets, and thought about how it's going to affect trade, and that was our first set of insights. Then the second set of insights happened around, I think, 2021, which is that we realized that the way we were thinking about AI was all wrong, in that we had been trying to identify the kind of jobs that would be most affected. And I think, like most people, we were fascinated by radiologists. We were convinced that it would be radiologists out of a job very quickly. That was like we made this confident prediction: radiologists, don't be a radiologist. And then we actually noticed in 2021 that was actually a terrible prediction. And we realized, too, that that's because we just hadn't really understood how AI as a technology was going to really echo other technologies in terms of its impact in the economy. Now, let me explain what I mean by that, which is that we were thinking about AI simply in terms of you had a task and then you replaced it with AI. And so that's why we were fascinated by radiologists, right? Their job is to look at unstructured data, make sense of it, make a prediction. We thought, ooh, that's where AI is going to be important. But then we realized we were making the classic mistake, which was made about electricity in the 19th century, in that we had thought then as, we thought then as a society that electricity was about replacing candles. It was about illumination. And so we were like, oh, electricity can light a light bulb. That's going to be the effect of electricity. But that was not the effect of electricity. The big effect of electricity was what happened when we rearranged factories to actually be running on electricity rather than steam, and the huge efficiency gains we got at that point. And so we realized then that, again, the effect of AI is going to be really about replacing systems in a way which makes it a lot more unpredictable, but in some ways a lot more interesting. So I just wanted to give you that background. That is how economists think about AI, and I have just done probably, the shortest shrift that anyone's ever done to an entire 5 years worth of intellectual endeavor. Okay, now with that said, I'm going to just tell you a little bit about the plan for my keynote, because I'm one person involved in this effort to bring what we think of as the benefits of some economic thought to the question of AI. And I'm going to come at this as the perspective of someone who has thought for a long time more about digital data, its origins, questions about privacy. And that's going to be motivating a lot of what I'm going to say in this keynote. So I'm going to give you that motivation. Then we're going to get to those equations and tables. And then, because I'm a keynote, my other job is to be a little bit provocative, say some things that you can all then shout at me about in sort of hopefully a more enlivened Q&A. All right. So how did I end up getting interested in questions about machine learning and artificial intelligence? It actually came from me because I have been for a long time a scholar of the economics of privacy. And I was at PrivacyCon, which is an FTC, Federal Trade Commission, organized event in this very town. And I was presenting some of my more usual work about privacy, where I was showing that actually people's preferences about privacy seem to be very unstable. And I was giving some data about an experiment we run at MIT, where all the MIT undergraduates started off by saying we really, really care about privacy, and then we gave them the offer of a slice of cheese pizza, and suddenly they were giving up all their data. So that was the experiment I was presenting. And so it was very sort of typical me, and then, and then I noticed I was literally the only person talking about privacy, literally at a conference called PrivacyCon. And I was like, wow, this is like different. And what I noticed was that the entire rest of computer science, law, policy, scholarship, and moved on to really be thinking about questions of algorithmic justice, algorithmic fairness. And this is, in some sense, one of the important policy questions, which I think is shaping a lot of AI research, and I got very interested in that. And so the typical example I was seeing at that FTC conference, this is the one which really struck me, is this example, which comes from LinkedIn. And where what's happening is that you type into LinkedIn, Stephanie Williams, and then LinkedIn says, oh no, you can't have possibly meant a woman. It must be the case you meant Stephen, and tries to correct you. And you can see here, this is sort of what we think of as AI as economists, it's machine learning in action, in that we got a machine trying to make a prediction about what you really meant, what you really intended. But that prediction is somewhat uneasy in that, of course, we worry that we are making predictions which may reinforce inequality. Now, after that, I got interested in this idea, well, okay, we have this explanation about algorithmic bias, that sometimes algorithms may make bad predictions or predictions we feel uncomfortable about because because perhaps the data they were trained on reflected some kind of bias in society, and that's the usual question. But I started to get worried, just because I've been interested in data for so long, about, well, given what I know about how messy, sparse, fragmented digital data really is, we've got now all this amazing technology, artificial intelligence, which we're trying to train on this data, but the data is still as problematic as it's ever been, even when it was more manual. And so I became interested in the question of how that is going to affect outcomes. And so I started writing about this idea of algorithmic exclusion. And this is distinct from the algorithmic bias literature, and it's just saying, look, algorithms can make mistakes, not because of how advanced the technology is, but just simply because data is missing. And I identified two reasons that data can be missing, both associated with privilege, which is data can just be sparse, not exist, and also data can be fragmented and difficult to match up. And both things will affect how algorithms perform. Now, let me try, and I promise you an equation, but let me sort of try and explain what's going to be different here. In that algorithmic bias is a literature, or algorithmic justice, usually you're worried about beta in this equation. And beta is the coefficient, you might think in a more traditional regression, which actually says, well, this is the interpretation we're going to put on the data when making our prediction. So everyone's obsessed with beta, and that we might get beta wrong because it's trained on the wrong kind of data. I, on the other hand, and this is where it gets nerdy, gets more excited about X. That's the actual data itself. And the fact that we're going to be training these models with missing X's in a way which could be problematic. So that's going to be the distinction, sort of intellectual distinction of what I'm doing here. So let's just go through this, and I'll give you an easy example of sparse data And then I'm going to go on to try and talk a little bit about how I've managed to document this in the real world. So my easy example is actually going to come from my hometown of Boston. And in Boston, as maybe happens a lot in the Northeast, we have a lot of potholes. We have our roads get a battering every winter. We have a lot of potholes. And so the Boston government decided that they were going to try and use technology to work out where potholes are. And this was a classic prediction exercise, and the idea was you were going to gather data from people's cell phones, and then when people drive, you're going to sometimes see dips, and you were going to use artificial intelligence or machine learning to predict what that meant about where the potholes were. Right, so it sounds really great, right? But what was the problem? Well, the problem was that they found a lot of potholes in Beacon Hill. And if you don't know your Boston geography, that's a really, really, really nice place to live, right? It's beautiful. It's got massive houses. It's, $1 million, $2 million to, get a studio. It's an amazing place to live. But that's apparently where all the potholes were in Boston, according to this data. And then at some point, none of the potholes were in any of the lower income areas of Boston, apparently. And if you've lived in Boston, you're like, no, that's not how it is. And there came the realization that the problem was that this entire prediction exercise rested on the idea that people would first of all download the pothole tracking app, and then not just download the app, but then have data running constantly in the background to be monitoring whether or not their car was going up and down. Both of those actions, the adoption of the app, the willingness to use unlimited and maybe an unlimited data plan to be constantly collecting data, they actually reflect a certain privilege in society. And so unintentionally, this very well-meaning machine learning project just went wrong because of having missing data. There were certain assumptions that everyone would be collecting data uniformly. We could train prediction on it, and it just didn't work. So I think my general point here is that having the kind of broad digital footprint, which gives us the kind of data that we're going to be using to train AI models to make these predictions, is often really a matter of privilege. I'm going to guess, both the people in the room and the people on Zoom, you're going to be spending a lot of time on computer work. In fact, every day you're just generating data at work. That's just what you're doing. You probably also have unlimited data on your cell phone, right? Allowing you to be constantly touching other digital touch points, creating data. Maybe you also got part of the Internet of Things. Maybe you're one of those people where your fridge is talking to you. I don't know. But the key point is that all of these acts of creating data reflect a certain level of income, status, privilege. And we're just training all our AI models on this unstructured data. And when you start to think of it that way, you're like, of course there's going to be problems. And so one of my aim here is that I've always sort of thought that the idea of a food desert is really appealing, right? In the US, you can immediately understand the problem that in poorer areas in the US, we have food deserts, and as a consequence, because we don't have enough stores, and as a consequence, often poorer households face higher prices and less selection. But I want to try and popularize in a similar way the idea of a data desert. That when we think about the data which AI is being trained on, there's going to be these data deserts where we're just not learning about certain households, certain people, certain lives. Now, the other thing I just want to highlight in terms of the problems, and this is where it gets really quite nerdy, is that in the end, data very rarely, which you're using to train these models, very rarely comes from a single source. I mean, if you think about it, we've just sort of said that we're getting data from cell phones, we're getting data from your internet use. We're going to be bringing together all these different data sources. And that's how we're going to make predictions, which are hopefully going to be beneficial. But then you also have to think that we have all these different data sources, which we're then going to try and use to make predictions, but these data sources have to be matched. And typically, how are data sets matched? Well, when you're trying to match them about an individual, you're often using something like a cell phone number, an email address, maybe a name. And what I want you to see there is that there's going to be differences in stability about, do I have the same cell phone number constantly? Do I have the same email address constantly? Is my name easy to spell, or are there going to be contexts where people misspell it? All of these things can lead to data not being matched about that individual, which means essentially their data is missing. Now, let me try and explain the effects of this. And as you've noticed, even though we're in the World Bank, we are talking about firms, so I'm going to be talking about a very commercial enterprise. In that, one thing I've been doing to try and understand these issues is looking at industry sectors where machine learning, artificial intelligence is happening now. We're going to hear during the afternoon and morning about health, manufacturing, retail, where perhaps the deployment of AI is more incipient. But I'm going to be talking about a place where basically machine learning AI has been sort of mainstream for 5, 6, 7 years, and that's the world of something called a data broker. So let me explain what a data broker is, what kind of firm they are, and then you can start to understand why they're interesting. So a data broker, you can sort of think of them as a vacuum of data in our economy. And what they do is they're trying to piece together data about, say, every single American. And they're collecting lots of different types of data. They're collecting data about perhaps from apps that you're playing on your cell phone. They're collecting data about your loyalty card. They're collecting data maybe from credit card companies about what you're buying. They're collecting data from your social media. And also, importantly, they're going to be collecting publicly available data about that individual. And they're going to take all that data together, and then they're going to make predictions. And this is exactly where machine learning, artificial intelligence comes in that their job is to basically make a prediction about the kind of individual you are, and importantly, what you might buy, who you are, whether you'd be an interesting person for a firm to try and target with advertising. And so you can see this is a simple prediction problem, and as a result, I'm going to argue they're a good place to start to think about, well, what's going to happen to the economy at large when we're thinking about how AI is going to be transformative and how it might be distortive. Now, what interests me too about data brokers is that you might think, when you sort of see that, it looks a bit creepy, that they're making predictions about you. That, and they're very sort of highly specific, such as Catherine is going to buy a brown coat tomorrow, something like that. But that's not really the predictions that people are buying. Instead, they're buying, firms are generally buying predictions about things such as your age, your gender, how well off you are, how educated you are, sort of very traditional background demographics. And what they're doing is that when a cookie arrives at a website, a firm goes to the data broker and says, tell me about this cookie, tell me their age, their gender, and then I can decide whether or not I want to engage with them with marketing. Now, the question is how are data brokers making these predictions about age and gender? And basically, you can sort of think about it with the idea of browsing behavior, which is that, well, maybe I could make a prediction that someone is female if I saw them looking at websites, maybe to do with tampons. That might be indicative. Maybe I could tell someone was older if I saw them browsing data on retirement homes. But you can already see the problem, right? I could be browsing a retirement home for myself, my parents, my grandparents. There are going to be a lot of very weak signals out there in the data we're trying to make predictions from. And so I want you to have that in mind. And what I'm going to show you, I think what makes this sector interesting, is they're trying to use a whole lot of data to actually make predictions which are going to be hard to make from the data they have in hand. Now, we're going to be asking how good they are at this And I'm going to show you some just level results, because we're thinking in general about how AI is transforming the economy, at how good it's going at the moment. And then I'm going to show you some results about differences across people and how well this works. Now, what we did to try and test this is we're going to get data from people who opted in to a panel. And we're going to find out from those people, they're just going to tell us whether they're a man, woman, their age, some other information. And so that's going to be our methodology. We're going to actually know something about a cookie because that person is going to have opted in and told us about it. Now, you might be thinking, okay, but they've just made their life rather easy here. I mean, this doesn't sound like a normal person. I mean, who's going to opt in and tell researchers that they can look at their cookie and then find out all this information about them? They seem to be a slightly unusual set of people. And I'd say, yes, we are looking at an unusual set of people in all these studies. But I'm going to argue we have found the easiest people to make predictions about in the entire economy. These people are just volunteering to be tracked. We know they're not going to be trying to disguise their digital footprint. They're not using Tor. They're not using ad blockers. Instead, these should be the easiest people in the digital economy to make predictions about. And then we're going to give the data brokers a relatively straightforward task, and we're going to say to them, you know, what age group is this person in? What gender are they? Are they male? Now, this is the headline result from this first paper. And the way you should read this table is we've got all the data brokers, and basically you can think of these as all the major data brokers in the economy. We sort of got around 90% coverage of the industry. We had around 30,000 cookies of people who opted into our study. These are the number of cookies that the data brokers said they had data on and who they were willing to make a prediction about. And then the final column is whether or not they told us correctly if that cookie was male. Now, what I want you to take from that final column is that when you read it and do some math, maybe it's early in the morning, you should be getting very close to around 50%. And when you think about it, the ability to get gender right 50% of the time is actually quite funny. And so this is sort of, I guess it's like the first headline, right? We're very worried about AI and machine learning, but we're getting, we're using it, deploying it here, advanced industry, advanced deployment. It's pretty much working like chance. So that's the first thing I want you to take from this. The other thing which is going to become important is, you remember I said we had 30,000 people. I want you to notice the wide divergence in how much data these data brokers are going to have about people. That's going to become important because I'm going to show this is going to be very correlated with people's status. The other thing I want you to take from this is if you try and do a quick correlation, does more data make you more accurate? The answer is no, right? This is just, no one's doing this very well. So we have this data, and then what we wanted to do was we wanted to then ask sort of the more classic World Bank question, which is, well, we can see that these predictions are pretty terrible. Who in society are they able to make good predictions about? Who are they making predictions about? And is it related to privilege or income? And this is what we found. The first thing we found is that if you're rich, if you have a college degree or above, if you own your own house, then that is when the data starts to become accurate. That's when data brokers are more accurately able to say, this person has this many kids, this person is female, this person is in this age bracket, this person lives in this place. All of these characteristics were the people who are actually being profiled accurately. Now, in particular, they were more likely to have demographic information, that kind of background information about them accurately. And we thought this was interesting in the following sense. In that, to get demographic information accurate, then often you have to piece together different data sources. You don't just use one data source. And so the fact that richer people have particularly accurate demographic information seemed to be, to us, evidence about this idea of being able to piece together data about people being important. In general, there were less differences in the accuracy of the prediction when it came to saying, oh, does this person like sports? In general, that's an easy prediction to make. Most people like sports. And you just really need one data source for that. Now, the next thing we did was we found this result about accuracy. But then, this is an academic paper, and our review team actually made us do something really interesting. And that they said to us, look, you're so focused about whether or not they get the answers right, but you're not thinking enough about coverage. That is, there's wide disparities in who is being profiled. Do we see anything in that in the data? And then when the review team pushed us to do that, we actually found a really interesting result, which is that basically not only are richer people more accurately profiled, but they're more likely to have a data profile being compiled about them. Poorer people, less educated people, people who don't own their own house, they're actually just missing in this data economy. And that's quite significant, right? That we just seem to not have predictions existing about these people. So then we tried to understand this a little bit more. And for the next study, I have to give great credit to my co-authors, who are computer scientists, who came up with this really nice way of trying to look at this in a sort of more micro way. And let me just explain what the study, and then I can explain what this graph means. Which is what my co-authors did, which was very clever, is that they realized that in North Carolina, we actually have public voting records. And it came as a huge surprise to me, but if you live in North Carolina and you vote, there is a record which will give your name, age, address, gender, and race. So we had all that data about people in North Carolina. And then what we did was we took some of these voting records and we uploaded the names and addresses to a major data broker. And we said, data broker, tell us this person's age. And we made it easy for the data broker, and that they didn't have to get the age exactly right. They just had to get it sort of right in the right age band. And that was how we were going to identify, number one, are they profiling this person? And number two, are they accurate about this data? Now, this is what I want you to take from this study, and we're going to be doing two things in it. The first thing is, I want you to look at the darkest bar, which is where there's no match. And that means we could go to a major data broker, ask the data broker about a prediction about this individual, and the data broker was like, no idea who they are, don't know. But remember, it's not difficult to know who these people are. Literally, their data is on the internet. It's public. It's exactly those public records that the data brokers are meant to be using. So we've made it, should be really easy for them, right? These people are not hiding, their data's out there, but the data broker's like, no, we don't have any data about them, we don't know who they are, we can't tell you anything. The other thing I want you to notice from this is just that when it comes to race, we're then going to see large discrepancies across race. Because remember, we got self-reported race. We are then going to be making a prediction about, then we're asking the data broker, do you know this person's age? And we see that particularly for Hispanic people in the US, nearly half of the time, the data broker's like, we don't know that person. And it's dramatically different from what we might see from someone who's white, where that only happens about 30% of the time. The other thing is we were also interested about whether the data broker got age right. And remember, age is out there, right? It's just on this voter record. And so, if there was a match, they generally got it correct most of the time. But you see, they tend to get it less correct or less consistently right for Black Americans. So we found this really interesting, both this coverage point and this prediction accuracy point. And my co-authors, who are a lot more careful than me, we had some suggestive results about the mechanism. And what we worked out, but it's a little bit less publishable, but I'll just say it anyway, is that a lot of the problems were coming from overlapping names. And it happens that Hispanic people in the US, Asian people in the US, often there's a lot of commonality in last names. And so, for Asian Americans, especially, if you come from Korea or Vietnam, we tend to have a lot of the last name. Similarly, Hispanic people, a lot of commonality of last name. And it seemed that the data broker just couldn't really cope when you had overlapping last names and they just didn't know how to even think about an individual. And so they gave up trying to make a prediction. And so that struck me again as interesting, in that these small little variations in circumstance background can lead to these huge differences in how well machine learning can perform. Now, a question obviously is that if I was to present this in Europe, at this point there would be, or maybe some of you in Europe will be chewing on. Generally there's sort of like a bit of cheers at this point. And what do I mean by that? Well, there's just this happiness that for once we seem to have a good result about the digital economy and low-income households. In that, one way of thinking about this is it's great. You've just told me that for once it's the rich who's really suffering, the poor people are actually not having been profiled. Isn't that great news? And I want to pause here, because yes, you might say that's good news from a marketing perspective, perhaps, if you don't like marketing. But remember, these data brokers, they're not just making predictions for marketing purposes, but they're usually attached to major credit bureaus. In other words, they are the businesses that are doing employment verification. They are the businesses that are, if you're a landlord thinking about whether or not you want to rent out your apartment, they'll be giving a prediction. If you're applying for financial products, there's going to be a prediction about your credit worthiness. And so at that point, I would say we start to care, right? In that I managed to get access to this data because I was looking at marketing, but I certainly think that the patterns I identified are going to apply too to these other more important predictions in the economy. Now, let me just summarize where we are, which is that I've been talking to you today about machine learning. I've been making, I think, this fundamental point. The machine learning, artificial intelligence as a technology in terms of how it's going to transform the world is still going to be predicated on the underlying quality of the data. And the big challenge is that data is both sparse, it's fragmented, and this can lead to algorithmic exclusion, where we have this AI-driven economy making predictions about people on the basis of missing or poor data. Now, the other thing I want you to take is that, yes, my study is about advertising, marketing, communications, and we might not care that much if there's an inequality in prediction there. But when you understand the mechanism, we should start to be very worried that we're going to be using this technology to make a lot of predictions on the basis of unequal data in really quite important economic areas. So how much time do I have? 14 minutes. Well, that's good, because I'm just going to be provocative, and then we can have some questions. All right. So this is a very, very provocative conclusion, which is that I, as an academic, I have been working on the question of privacy for just about my whole career. And these set of results have made me worry that really what I've been studying is a rich person's problem. And, that's perhaps not surprising. We've got some results in other people's papers which suggest that richer people tend to have stronger privacy preferences. If we look at, say, sign-ups, the do not call lists, they tend to come from rich zip codes. If we look at ad blocker use, again, they tend to come from richer households. And so we've worried a lot about privacy, but it tends to be a preference of those with status and who are well off. Perhaps we should also be thinking, though, about this idea of data deserts. And that if you're lower income, rather than just being concerned about privacy, another worry is that a lot of the background circumstances which might lead you to have less stable data, perhaps you're constantly changing your cell phone number, you don't have a stable email address, you don't own your own home, you don't have a fixed internet identity, perhaps all that inaccuracy, which is going to come from predictions from that poor data, is going to be a bigger concern. And so I guess one sort of thing I'd like you to take from this is when you hear privacy, I just want you to also think about data deserts as sort of being a parallel problem, which we talk about less. The next thing I want to talk about, just again, because I know there's quite a few people thinking about policy here, is that as a society we have been thinking a lot about how do we regulate algorithms, how do we regulate AI. And we worried a lot about algorithmic justice, and I think we've gone through sort of iterations about thinking about what to do. We first of all started off thinking maybe we just need to make algorithms AI transparent, but then we realized you just have to go to a computer scientist and say, show me your AI code, and they would just laugh at you, right? That's just not the way it works, right? So algorithmic transparency is probably not going to work. Now, I think what my work is saying is that the next policy that we moved on to as a community, which is algorithmic auditing, or the idea we just have to look at how algorithms are performing, doesn't really address this. And that neither of these policy impetuses have really been focused on the question of what you do if AI is just not making predictions about large swathes of society because there's missing data. And so again, even when we're thinking about, how to regulate AI, how we might ensure algorithmic justice, I want to sort of put in a voice for missing data and thinking about, well, how are we going to change that if we ever want algorithms to perform all the good that we really think they can do. So with that, I'm at the end of my provocative conclusions, and I hope we're going to have some time for questions.
Thank you very much, Catherine. It's a pleasure for you to come and join us today and for us to learn from you about your new research, in particular on the fragility of data when making predictions. So I'm going to start first by taking some questions from our online audience, which we have several hundred currently watching right now from Asia, Europe, and North America. And the first question I'd like to take is from Valerie Delisante from Peru. And she asks, given this issue for the lack of data, and we've discussed it more likely in the context of developed countries, how can AI help communities in developing countries, given that there's likely even a larger lack of data in those regions?
I mean, that's such a powerful question. So let's be clear. My paper was exclusively about rich countries. I didn't sort of say the countries, but, I told you about the US. I think we also popped in there in some of the studies, the UK, Canada, New Zealand, but all, again, countries which have a digital data economy. Now, how much worse are my findings going to be if we're in countries where I would say these problems are even exacerbated? I can only imagine they're worse. And let's just sort of think about why that is, because that might be even sort of more troubling for Valerie, which is that in the end, the reason we study these countries is these are the countries with these big digital firms, right? Where we could actually see what predictions they're making. When we move outside of these rich countries with households that people actually want to market to, we don't even have this digital apparatus. And so what tends to happen? Well, you end up using these data brokers are selling predictions trained on New Zealand, Canada, Australia, the US, right, to make predictions about households in these countries. And that's really troubling, right?
Thank you very much, Catherine. One other question from people online. What should governments do to reduce these data deserts while maintaining the privacy of individuals?
Oh.
We're not giving you easy questions.
This is like, not picking an easy one. So let's talk a little bit about this to help sort of think this through. So I always think a good way of thinking about this is something like the Aadhaar program in India. So, I know we've got we got a lot of people who are working over in Asia in the World Bank here, so I don't want to be, to talk too much about Aadhaar. But for those of you who don't know what it was a government program which tried to give every single Indian citizen an ID. And the idea was that, people lacked IDs and this was going to be problematic, and so they were trying to address it. Now, what we saw in India at the time was, unsurprisingly, a sort of universal ID surveillance system did not rest easy with many households. And in particular, in wealthy areas, we saw a great deal of unease about what this monitoring might mean. But, and the big but, is that what it did allow for was a great deal of financial inclusion, which never existed before. In that finally you had a way, perhaps, of cobbling together something that looked more like a credit record, and you could actually get access to liquidity if you were lower income. Now, the reason I tell you that is that you'll notice I'm not answering your question, and I'm basically saying there's a huge trade-off here. In that, what I take from that is we're going to, in some sense, if we want to have that inclusion in the digital economy, we're going to have to accept an expansion of data collection, and that is naturally going to make those, particularly in privileged positions, who've got these strong privacy preferences, feel uneasy. And I wish I could give you a solution. I love the way she said, the question was, can you do this and protect privacy? No, I think there's actually a trade-off, which we just don't recognize when we're making privacy regulations.
And I think that's why your work is so interesting and thought-provoking for policymakers, because these are the real types of questions that we're going to have to grapple with when we think about making sure that algorithms work for everybody, but then making sure that people feel secure with the ways in which they share their data, particularly online. Given the time constraint, I'd like to open it up to questions to people in person in the audience. Do we have any questions? If so, please raise your hand and somebody will bring a microphone to you.
Can I ask a quick question?
Please.
So, Catherine, this is a brilliant talk, but you presented this as a somewhat egalitarian problem in the rich people's concern about privacy. And I think you're absolutely right that it is a luxury, especially the nice example of credit bureaus and so on, which thrive on information and improve access to finance for poorer people. But if you think about monopolistic, perhaps manipulative firms who are represented here, tyrannical and also manipulative governments, and the individual, how do we think about the trade-off that you just described between improved access to services, both public and private, but also the vulnerability that comes? How would you advise the Indian government or a government in a developing country to strike the best trade-off?
All right, and I should be clear that when I say that privacy is a rich person's concern, I mean that when you measure the strength of desire for privacy, it tends to be, as you say, a luxury taste, a taste of the rich, right? We see it less expressed in terms of preferences from those from lower income. Now, I think the answer to your question is going to be depending on what the prediction is. You notice we've been talking about it very generally. I love the way you went like manipulative, evil. You know, if it's manipulative and evil predictions, maybe we should be almost celebrating that we have this disparity. You know, and this is the example I would give of where we might think that some of this, you could actually be cheering these results. If we're, say, thinking about a policing prediction technology, right? As we know, often policing and surveillance is not equally distributed in society. It's often targeted at lower income, the more vulnerable. Actually there, if the data's worse, for once we've got a natural counterbalance. So the way I would take this is that, again, maybe if we'd had some more nuance to the policy, right, we're going to be very worried about this when we're making predictions which are for the good. That is, the prediction that this person will be a good tenant, the prediction that this person deserves credit. These are predictions for the good. But you're right to say, no, that these predictions for the bad, right, where maybe we're going to be cheering on the fact we actually have this disparity.
Do we have any other questions from the audience? Yes, please.
Yes, thanks a lot for a beautiful presentation. From the fund, from the IMF, and I actually working on Peru right now. So that first question was amazing. Coming back again to Latin America, so informality is huge in Peru. It's about 70% of the economy. On the other hand, kind of training an AI algorithm is very costly, and it's kind of these algorithms are created only in wealthy countries. So for a company like OpenAI, does it make sense to collect data on Latin American countries? I mean, to collect data on these people from informal sectors, and if it's not, it doesn't make sense for these companies, should be kind of a policy. So what would be a policy recommendation for organizations like World Bank? Is there something the World Bank can do to collect this data, to create incentives to collect this data, so that kind of these countries, these societies, are better represented in their AI algorithms?
So this is such a beautiful question, and what I loved about it was it really clarified in terms of economics the two challenges, right? We have the fact that because of informality, as you say, we don't, and a lack of deployment of digital technologies, data is just a lot more costly to collect than it is in America and Europe. That's the first thing to say. The other cost, though, is that right now, if you're using a generative AI model, what we might call a foundation model, to make predictions, that's really expensive. The marginal cost of a prediction is actually high, and that is shaping a lot of the business models of companies like OpenAI right now. Now, if I was to get to order the World Bank to do stuff, which I don't, but I'm going to pretend I do, this is what I would say. I would say, look, in the end, what we know about the costs of prediction is they always come down. So in 5 to 10 years, I think that marginal cost of prediction is not going to be so much of an issue. But the data is still going to be an issue. And the fact that, we just don't have data being created is an issue where, again, I think we can sort of think a little bit about what it is that we could do to at least try and think about how can we make sure these data sets exist when they don't. And I think this generalizes too. I don't know if this is true because I don't speak Hungarian, but if you try and use ChatGPT-3 in Hungarian, it is a very, very different world from the one we know when we are, for example, when we're using English. So I think we're going to see these discrepancies again and again, but they're all going to be this combination of the cost of collecting data, the high cost of prediction, and, expected profits from making that prediction.
I think that's an excellent answer to a great question, which transitions us nicely to the next session on AI and health, where I think having fewer data deserts on people and health conditions can lead to greater life expectancy and improved health. So Catherine, thank you very much for your talk, and thanks for all the questions both online and in person. Thank you very much.